Hello friends, welcome to BISP Solutions, and today is our third webinar. This is a boot camp on Pytorch, right? In our last boot camp video, in our last boot camp session, what we have seen, we have seen the linear regression, right? That is related to machine learning. Now here I am going to show you today the linear regression, how linear regression is applied where more than two independent variables are there, right? In my last session, what I have shown you, one dependent variable and one is independent variable, right? So in this bootcamp, how independent variables are there and one dependent variable, right? For example, let me give you one example here. For example, let's take insurance example. What example is that? In insurance example, how much for example, we need to take different parameters of the person. For example, whether he smokes, what is the financial condition of that person, how many members are there. For example, if an insurance agent reaches out to you and he says that, sir, you should take insurance policy. Now in that insurance policy, only based on one condition, he will not suggest you the insurance amount, right? So what he will do, he will take so many parameters. Number one, what is your monthly income, then how much what is your the condition of your health. Third thing, whether your how many members are earning members there. Fourth, how many kids you have. So these are the parameters on which the decisions are taken, right? Now let's see this, how this linear, there are two types of linear regression. One is simple linear regression that we have already discussed yesterday's session. I recommend you to watch my yesterday's bootcamp video, right? Secondly, this multiple linear regression. Multiple linear regression means there are, you can see here, dependent variable, that is y. Now dependent variable, there are so many dependent variables, right? And here m1 m2 is the slope and c for coefficient. Now what are that I will explain you during the execution of real code, right? Now see here what thing is done. First of all, get the data ready, right? So first of all, we take the Excel sheet or whatever the data, right? But actually the data is received in the Excel sheet, so that is why we take the data. Then build or pick a pre-trained model, right? Now in this pre-trained model, what will happen? First of all, we will pick a loss function optimizer. First of all, we create the tensors, then we create a function, pre-modeled function, right? Pre-trained model, and then we create the function of pick and loss. I will show you where this pick and loss is used. Then build a training loop, what we say the epochs. Here the term epochs is used for the iteration, right? Then what we do, then we fit that model into the data and make a prediction, and then evaluation is also done, and then we improve through epochs, that is one by one the loop is running. After that, save and reload your trained data. For example, what is train and test? Exactly, what is train and test? For example, let's take an example of a student, right? A student, he reads the course syllabus books whole year, right? And hardly that 20% of the course is asked into the exam. I'm just giving you an example so that the picture becomes clear to you. This is called 80% trained and 20% test data. You read whole year and out of that only hardly 20%, then that means here that 80% becomes the trained data. You have read whole year and then hardly 20% of that course is asked into the exam, right? Now see here, data preparing and loading. First of all, what thing is done here? See here, first of all, suppose this is an image. Let's take an example. Turn data into numbers. This is the part 1. Turn data into numbers. Now either the data could be image, either the data could be numerical value, digital value we can say, or the data could be the voice. So all these things, first of all, they are converted into the tensors, right? Tensor is nothing but a matrix of numerical value, because machine understands the language of numerical values, right? After that, second thing, the part 2, that is the build a model to learn. We have to first build a model in which the pattern is the model that learns the pattern, right? And then after that, output is created. Now output is automatically created by the machine module, that is a Pytorch, and then again it is converted into the output. For example, if you input these two images, right, ramen and spaghetti, now first of all they will be converted into the matrix, that is the tensor, and then with the help of model that we are going to learn very soon, and then that model converts that data into the output, and then if it's an image, then it will give you the output of ramen, spaghetti. Otherwise, here if you give the output of an email, right, so not spam, it will check it out. Then otherwise, if you provide a audio file, in that case it will be converted into the tensor, and then with the help of machine modeling, it gives you the written output, that is, hey Siri, what's the weather today, right? Initially I have given you an example, splitting our data into train and test. So that's a real life example of a student, right? Same thing here, we take 80% of the data for training purpose, and then the test, we do the testing on remaining 20%. That's the process of Pytorch, right? So after that, now see here, okay, let's see here. Yes, here you see, this is the train model, how this model works, right? So for example, object, that object is given into the tensors. After that, this tensor output, right, this tensor input, and then it is forwarded to here loss functions. Then this loss, with the help of this back propagation, it repeats again and again, and with the torch model it optimizes first, and then it gives you the output as an object. We will see the complete process now. See here, suppose I have some data of the users, right, and that data I have kept into this insurance.csv file. So for easy understanding, let's do one thing. I will create a new interactive Python file, right, and Pytorch prediction on insurance bootcamp, right? I have already created one file here, but we will go step by step. Let's make it Pytorch prediction. Right, that's it, rename it. Okay, now for this what we are going to do, we will first see exactly how this complete code works, right? So I have already one file here. First of all, what we will do, let me minimize this. Okay, so first of all, now see here, okay, now see, it will take time, a little time. It will bring all the necessary libraries. First of all, pandas. So let's discuss on pandas. Exactly, panda is a library that is supported by Python and right. Just a second. then scikit-learn model selection, import train test split, right? After that, from sklearn pre-processing standard scaler. So these are some necessary libraries that we need to import, right? Then let's go here, just a second. Yeah, now what happened here, suppose first of all what we need to do, we have to import the insurance file here. Now this insurance file here, df means data frame. Just take a variable pd means pandas. That means we are asking the pandas to read the csv file. Now read the csv file from where? Directly we have here the insurance.csv. This is our file here, bootcamp, and this is, so that is why if it is kept into the another folder, then we have to put it something like this. Let me show you that. Content / insurance.csv, right? So but since the insurance file is kept in the same folder, so we don't need to do. Now here head, suppose what if I put here only df. Now see here, total 1338 1000, but dot head, okay, dot head means top 5 rows. Now see here, if you talk about the, see every what we say, every item requires different every wherever we take decision on any parameter, we need different dependent variables. Suppose if you talk about the insurance policy, so what we need, the talk about the insurance policy, so what we need, the person's age, the body mass index, the children, how many children, whether he is a smoker or non-smoker, in what region he resides, and what are the charges. That means what would be the insurance policy amount, right? I'm giving you one more example. Suppose if a company or a businessman wants to open his shopping mall in a particular city, so there is no one parameter required. There are so many parameters. First of all, shopping mall needs to be opened in, suppose, city A. Now first of all, one parameter is how many IT colleges are there and how many IT companies are there, because the spending capacity also matters, right? Suppose if you open a shopping mall in a village, there is no use. So first thing is how many IT colleges are there, what is the scope of education in that city, what is the living standard of the people in that city, right? And what else, how many English medium schools are there, and what else, how many English medium schools are there, then businesses are there, then how what is the infrastructure of that city, and whether that city from that are connected, so what is the connectivity of that city with other cities, right? So these are the parameters which are considered. Similarly while prediction on insurance, so I am giving you one policy of insurance. So what will happen, I will ask that what's your age, because if the age is more, then in that case I will suggest you different policy, right? So that is why age factor is most important. Body mass index, now body mass index, it means that, for example, if a person is too much weak or too much fat, so that will also affect. So I will suggest you some other policy. So how many children, suppose if a person is having 5 children, and suppose if he is a chain smoker, so these are the parameters that are required, right? So parameters varies from plan to plan. Okay, now see here again, what we are doing. Now see here, first of all we have taken out, first of all, see, this prediction techniques does not work on alphabetical values, right? So these things works on numerical values. So what we need to do, first of all we need to convert all the values, that is alphabetical values, we need to convert it into numerical, right? So df sex equal to male for 1 and female for 0, smoker yes 1, no 0, region northeast, northwest, southeast, southwest. Now again if I show you, now see here, everything is converted into numerical part. Okay, now what will happen? Now our task is much easier. Now we have to first extract what are the dependent variables and what are the independent variables, right? So let's go ahead. Now see here, now see, dependent variables independent variables are all related to x, and y is the dependent variable, charges. For example, if I come to you and if I say that sir, I'm selling the insurance policy to you, so what are the independent variables? That means whatever your living style, how many children you have, which are already done. And what would be my suggestion? That is depending on what the inputs that you are giving to me, right? So that is why we take charges. That charges means it's just a insurance policy amount, right? Then x equal to, from here x df dot drop charges. That means we have taken a variable and from this data frame, this above data frame, we removed that charges, and remaining everything we keep into the x, and y equal to df dot charges dot values. Now if I do this, invalid syntax, I think this pipeline is there, right? Look at this x. Similarly y, this y becomes separate, x becomes separate, right? Now we are having two variables, that is x and y. Now this Pytorch, it's a very big engine. Now we will supply this x and y value to this Pytorch, right? And inside that, this Pytorch will calculate everything based on this data, right? So it's very interesting. So I recommend you to watch this video after this bootcamp again, right? So now see here, if I print this, now look at this, 138, x shape is 138, y shape is also 1338, right? Just a second. Okay, now see here, once x train, now see x train, x test, y train, y test. See, both the x and y variables are separated. Now x train, x test, y train, y test is a formula in which we split the data. Now we split the data into 80-20%, right? 80-20%. Now 80-20% means same as I have given you since the beginning of this session, that 80% means we are training the 80% data and testing is done on the remaining 20% data. And this state 42 is written, random state 42 is written. That means every time when I run this code, the data should not shuffle, right? So suppose if I enter this again, if I enter this, same thing, same data is coming. Look at this, why this 1070 is not shuffling, and if I remove this, it will start changing the data. So that is why we have to keep consistency. Now let's move ahead. Okay, now if you see here, standardize, now standardize the feature. Now see here, transform. Okay, just a second. Yes, now standardize the feature. Now scalar, standard scalar. Now xtrain scalar fit underscore transform. We have to first transform the data. See, directly this is the numerical value, right? So we have to first standardize, that means what we say, transforming the data. Suppose if I ask you what's your family status, so I have to first write the complete details into a standard format. then only I can suggest you, then only I can calculate the insurance policy amount, right? So same thing happens here. Now if I click here, now see, extend, we have done the standardized process. Now convert it into tensor. Now the real game begins here. Now see here, now so far this PyTorch will not touch this data up to this point. Now we have converted into the tensors. Now tensors is the language that a PyTorch can understand. Look at this. Where is that ramen spaghetti? Just a second, let me open that. Here it is, conversion of data into tensors. Now same thing we are doing here. So what we are doing here, convert to tensors means extend torch.tensor, extend data type torch.float32. By default value is float, we have to put float32. Then xtest means torch.tensors, xtest comma data type, that is the torch.float32, ytrain, similarly ytrain, and then ytest. Now this data is converted into the tensors. Okay, now what will be our next step? Now linear regression model. Okay, now next steps begins here. Now see here, now see here, linear regression model is a class, it's a function. Then what it will do, first of all, this is a standard function, we don't need to do anything. Input dimension, that is xtrain shape, output dimension, that is 1, and then model linear regression, input dimension, output dimension, print output. So let me show you this, 6. Actually it's a number of, see here, number of columns. Look at this, 1 2 3 4 5 6, because charges is different, so it is just a column count, right? Now let's come to the next. Here you can see, if I go here and now see, define loss function and optimizer. See here is loss function and optimizer. Here you are optimizing the data. For example, let me take the same example, that I am an insurance agent and I am asking you that what's your age, what is your body mass index, how many children do you have, how many income do you have, how many sources of income, how many earning person do you have. So all these things I will first take from you, then I will write down into a standard way, and then I will calculate, I will do the optimization on that data, that if how which better policy shall I give you, right? Shall I sell you which better policy? So in this way, this is done into the Pytorch. So that is why optimizer function, create an, just a second, what's happening here? Now see here, optimizer function is working here, right? Now let's see, it's taking time. Okay, now see here, import matplotlib. Now see what we are doing here, we are importing the matplotlib. Now what is this matplotlib? See, matplotlib is a library, matplotlib.pyplot. It's a library and it is used to plot the data, plot the graph based on the data given to this function, right? Now see here, losses equal to, right now it's an empty array, and epochs equal to 100. Now this epochs means it's a repetition. Now in this PyTorch technology, PyTorch term, we call it as epochs. For epochs in range, epochs, then forward pass. Now y prediction, model extend, right? This is the extend. Similarly, loss criteria, y prediction, ytrain, and losses dot append equal to loss dot item. This is standard way of writing. Now see here, optimizer dot zero gradient and loss dot backward. Now this epochs plus 1 %, percentage 100, percentage 10. Now we have given the formula here, and now I am going to run this. Now what will happen? Let's wait for 2 seconds. Now see here, these are the losses. Look at this, right? So these are the losses, these are the technical terms, and it has shown you the loss. That means the difference between the actual and the predicted value, right? Then look at this, evaluate the model on the test set. Now we are evaluating this model, right? So here you can see y pred test, that is y prediction. Here you will see y prediction test equal to model x test loss is y pred test and y test. So everything is done on y prediction test and the test, and with this evaluation, this is an evaluation function. So look at this, this is the loss. Now where it is used, let me show you this also. Now if I go here, plot training, within few seconds it will be clear to you. Now see here what I have done, plot.training loss over epochs. So whatever the training data is there, we have put it into the plotting data, and then see here, if I click here, now see how image, what slope is coming, training loss over epochs. See here the loss is very high, right, initial, and as the epochs runs, the loss becomes very low. Look at this, this point is 0 coming down, that means the loss is less. Here you see, so if it will be much lesser, right? To understand with this plot. After that, now do one more thing, just a second. Here if I go, now see here, again evaluate the model on the test set and plot predictions. Now the original thing, that is plotting the data, right? So now what, let's see here, model evaluation with torch, no gradient, and then y pred test, prediction test, that is model x test, and test loss criteria, that is y prediction test and y test, same as previous. Then y prediction test, that is numpy with the help of numpy. Now again here numpy library is used, and then y test equal to y test dot numpy. Now see here, seaborn, this is another library that is used for plotting the data. Same thing, matplotlib is also used for plotting the data, and then seaborn is also used for plotting the data. Now if I click on this, one image will appear here, MSC loss is given, and here one image is appearing here, right? Now look at this, there is a lot of difference here. Look at this, this is the actual value, right? This blue color dots, this is the predicted value, but there is a loss here, so much difference here. Look at this, this blue dot is far away here, this dot is also far away from this line. Actually the expectation is that all the blue dots are just attached with it, with this they should be located just side by side. That is the expectation, but here you can see here total loss, test losses, it's too much, right? Now what we need to do, we need to, again this is what we have done with the bulk data, but now what we are going to do, now new data example, we have taken a single person example we have taken, and then on the basis of that we have predicted the data. Okay, now here you can see here I have taken the age 40, any random person, he is a male, because 1 means male. Look at this here, somewhere we have written here 1 means male, right? Similarly if you see BMI is this, children 2, smoker no, region 1, and new data equal to this, right? Open here, scalar fitted on training data, new data equal to scalar dot transform, right? That is the new data, we have to transform that data, new data, convert to tensor, again same thing, converted to tensor. Then model evaluation, we have sent this data for model evaluation with torch dot no gradient, and then extract the single prediction value. Now let's enter the hit button. Now see here 8197, That's the insurance policy, insurance charge amount. So is done. See, there could be plenty of examples that you can see in which the decision is based on multiple values, and in those cases this type of prediction values, where prediction techniques are used, where multiple prediction techniques, right? So now let's have a quick recap, and then again I will show you exactly what happened from beginning to end, right? See here, first of all, pandas library, we have to import all the necessary libraries. Clear? You just try to relate with the real life example that I have given you, right? Then df equal to pd.read csv, we have read the csv file, initial 5 values are here, then all independent values are kept into x and dependent kept into y. First of all, we have to convert them into numerical values. After that, all the dependent values are kept into y, that is only one value, that is charges, and remaining all are x, right? After that, you can see here the shape, data train test model, train test split. We splitted the data into 80-20 part. 80% means the training data, test means 20%, right? After that, what happens here? Standardize the feature. We have to standardize the feature. We have to transform the data into the X train and X test. Then convert the tensor, convert to tensor. Thus, whatever the data fitted here, that is converted into tensor, right? Then linear regression, define the function is already defined. We have to pass the data into that function. That okay. Input dimension equal to initializing the model, right? So this, it will give you the output, right? After that, criteria, define the loss function and optimizer. Criteria equal to loss function, we have to find it by this way only, right? There should be no change in this formula writing, right? After that, import matplotlib pyplot. Now this pyplot function, what we say, show your data into picture format, that is the plotting of data. Then we have taken epochs 100, only 100 we have taken here. So for epochs in range and y prediction model equal to x train, and then we have taken the prediction based on x train value. Loss equal to y prediction x y train, then losses dot append loss dot item. So these are the fixed standardized formula. After that, backward pass and optimization. We have to do the optimization of this data, and ultimately we see here the loss. It is not equal, same, right? So that's the good thing. It is different, and there is a lot of difference here. See here, it is showing exactly, it is showing the loss, right? So now if you see here, model evaluation, so torch dot no gradient and y prediction test, that is MSE loss, it is showing MSE loss, and based on that only we have plotted the data, and we come into conclusion that the more evens, loss will become more less, right? After that, evaluation of model we have done with the help of torch dot no grade, and then y prediction test. We have just supply the value here, and then ultimately finally in import seaborn as SNS, and that this seaborn library shown you the data like this way. This is not 100% accurate, but yeah. Now what we have done, we have taken a single record and apply this technique into that single record. So we have specifically taken this single record, and then scalar dot transform new data, and finally you can see here new data tensor, and then evaluation value, prediction, insurance, charges. Finally we get this, that is 8195.